Let me show you how I think of the cloud. This is the way I think about the cloud just generally. Not necessarily Windows Azure, just cloud in general. The way I would explain it to my bosses or tech execs, if I were in your shoes, would be something like this. If you were to go out and build a brand new office for your company, when you do that, you wouldn't be thinking about building a power plant and a wastewater treatment plant behind your office to deal with those sorts of things, right? I mean, I hope that's not what you're doing. I hope you're thinking about building a structure and an office building to help drive and develop your businesses. We don't ever think about those kinds of things. However, we always think about building data centers. We always think about building server rooms in our office buildings. And we spend a lot of time and money doing that. And so what the cloud does is kind of turn that upside down and says, you know, we shouldn't do that. We should think about the data center just like we think about power and water and everything else. Think about it like a utility. Plug in, pull what we need off the grid, deploy our apps, use that grid, and just pay for what we use. So not only are we just pulling what we need, but we're paying for it on a consumption basis just like we would water and power and bandwidth and everything else. So that's the way I like to think about the cloud, and that's the way I like to explain it to senior leadership and tech execs at a very high level. Now, there is a gentleman that used to work here at Microsoft. He actually used to run the server and tools business here at Microsoft. And his name's Bob Moogley, and I think he defines cloud really well. Very concise, succinct sort of definition. I'll let you read that. And then I'll point out a couple of high points in here that I think you should understand and think about. So the first thing he points out in this quote is just-in-time provisioning. Meaning, on demand, I want a server. I want a database. I want some sort of storage. So just-in-time, real-time, that happens. Not only just-in-time, but later on, he mentions kind of as a service, and on a pool of hardware and all this sort of stuff. But in this just-in-time, I'm also expecting self-service. It's kind of packed in here. But I also want to do it myself. I don't want to have to call up a vendor or call up IT or submit a ticket to get VMs provisioned. Then he goes through and talks about things like scaling. That's really important. We expect to have this elastic capability where we can say, I need 1 server today and I need 5 tomorrow. And he goes on to talk about services. We expect some abstraction over that. Scott talked a little bit about that this morning with the REST API. We expect an abstraction over the top of the data center so we can automate things and do things a little differently than we have in the past. And then lastly, he drives on this pool of hardware. And that's really important. We're talking about this sort of economy of scale. And basically what that means for us as consumers of this cloud service is we all have different workloads. Anybody here in the retail business? Okay. Well, if there were folks here in the retail business, they would see about 40% of their demand in the month of December. And then the other 11 months, you know, kind of split that load out pretty well. If you were in the pizza business, anybody want to take a stab at when that high point is? Like, what's the busiest day for the pizza business in the U.S.? Super Bowl Sunday, right? So they go crazy, and then we have things like, you know, the IRS and all the tax businesses built around the IRS that peak out in April, and we have flowers that peak out in February and all that sort of stuff. We all have different workloads. And so by putting all of us in a data center, we can take advantage of all of that hardware and level out over periods of time and get these economies of scale. We also get all sorts of other economies of scale, like just consolidating all the staff and what have you. So Moogley, I think, says it well here. You guys may have seen this kind of slide before. This is basically just walking through this transition from what we've done traditionally on-premise. So this is our data center today. We manage everything in the data center. We actually manage things even below this. We manage things like the real estate and the power and the cooling and all that sort of stuff. As we transition to the cloud and we get all the way to the right, for example, we give that all up to a vendor. So if we were using like Dynamics CRM or Office 365, for example. That would fit in that software as a service category. And we would give that all to a vendor, and we wouldn't worry about any of this stuff. We're going to focus primarily on the infrastructure as a service and the platform as a service space today, but this is just a high-level overview of this landscape. So this is a way to look at Windows Azure. It's kind of like a city, right? But we have our on-premises stuff today. We have things going on in Windows Azure. Maybe it's websites and cloud services. We have virtual machines running. We have databases running. We have background tasks working. Things like, think about things like Windows servers and batch processing and what have you. And then we have storage like table and blob storage in Windows Azure. Now, one of the things that Scott didn't talk about a lot this morning was storage. And so I'm going to quickly show you what storage and cloud services look like. I'll give you a quick view of cloud services. This is the gist of how a cloud service works in Windows Azure. Traffic comes in through a load balancer. Scott kind of showed that off this morning. And that load balancer distributes out to VMs behind the scenes. In a cloud service, I have a couple of types of VMs. I have a web role, and I have a worker role. Worker role, think about that like those background services running, the batch processing, things that you may traditionally do in a Windows service. It could be more than that. We could use a worker role to host up some other kind of application, like our own custom proprietary web server, or maybe it's Apache Tomcat in a worker role. But it's just basically a main entry point that I can do whatever I want and run some stuff in the background or host up something else. A web role, think about that just like a worker role with IIS pre-installed. So we get some VMs in Windows Azure in our cloud service sitting behind a load balancer. IIS is pre-installed. We run our web apps on them. We run our background processing on them. We need to store our data somewhere. So inside of Windows Azure, there's a storage service. And that storage service exposes a few different types of storage. First is blob storage. Blob storage, think about that like storing files in the file system. Today, if you were building a web app and you wanted to store images or documents or multimedia files of some sort, you may do that in blob storage in Windows Azure. So in blob storage, it looks like this. We have an account. That's our Windows Azure storage account. And we have a container beneath that account. That container, think about it like a directory or a collection of files in blob storage. And then if we move on down, we have the blob itself that is part of that container. So our photos or our movies or whatever it is that we're storing. Now, it's important to understand that this storage mechanism is not, we wouldn't use the traditional file I/O namespaces and classes in .NET to access this. So there's a new REST API that exposes all of this storage, all the storage services in Windows Azure. There is a .NET SDK that wraps that. So we do have a nice, friendly .NET set of classes to use, but it's not the normal I/O namespaces and classes we would normally use. Who in here is doing something with a NoSQL database today? Okay. Things like Mongo, and there's tons of NoSQL vendors today. Table storage, think about that like a NoSQL offering in Windows Azure storage. Now, I want to be careful. A couple of things that are commonly misleading. Tables does not reflect like a SQL database or relational tables. That's not what table storage is all about. Table storage is all about storing entities. Think about property bags and just a set of key value pairs. That's what table storage is all about. So very much like blob storage, we start with an account. We have our storage account. We dive into a table, which is a collection or a container of data. And then from there, we have these entities and property bags that we store. Again, REST API, .NET classes that wrap this. And then last, we have queues. Now, a lot of folks don't think about queues as being something that we would classify as storage. But the reality is a queue is a persistent piece of storage. In Windows Azure, this data is persistent. It's not going to disappear on you. It has a very similar structure, account. You'll see this kind of pattern over and over again. We have our storage account. We have a queue, which is this, again, container or collection of these queue messages that we have, which could be communication between a couple of different servers in our Azure environment, or just some sort of messaging. All right, so let's get into our business case and give you a quick kind of primer on Windows Azure. So I think it's very important for us to think about real-world sort of business scenarios. And so I have this real-world scenario with a datum. Datum is a typical Microsoft fictional company. Things like, a company like Contoso and all of those that we see in demos. And datum has some challenges. And I think it's important for you to think about these things like, think about the business cases and why we're doing things. I think oftentimes we get bogged down with technology, and we do really cool stuff, we build really cool stuff, and we lose sight of why we're doing these things. And so, just even as a career sort of thing to think about, if you start thinking at that higher level and start thinking about the business challenges and start talking about the business challenges, that potentially is good for your career advancement as well. So, not getting bogged down in tech. So, for our datum, we have all sorts of challenges. Right now, we have some long deployment times. So a datum is a fictitious company. So we manufacture widgets. We have 5,000 employees, we'll say. We have a lot of Microsoft technologies. We have legacy systems as well. We have legacy like mainframe, AS400 sorts of systems as well. So all sorts of stuff, but our developers primarily are Microsoft developers. They get things like .NET, ASP.NET, Visual Studio, the things that we all love and use every day. We have Active Directory, System Center going on in our enterprise, and we have tons and tons of applications in our portfolio. So, challenges, deployments are taking too long. We have underutilization of hardware. So we have a massive data center. You guys may be able to relate with this. We have tons and tons of servers. And for the most part, they sit at a very low utilization because we have them kind of dedicated to a purpose. And so generally they sit at somewhere under 5% utilization most of the time. And we have an expensive cost of failure. So when something does fail, we scramble, right? And we all go focus on this failure and try to figure out what's going on. And sometimes our debugging methods aren't all that great. And so we just start throwing solutions out there without really understanding the problem. Anybody do stuff like that, right? This will fix it. Oh, no, it didn't. Let's try something else. Nope, it didn't. So we just keep trying things until something works. So the cost of failures is very expensive. It takes people's focus off of what they really need to be doing. So the datum has a set of goals that they want to accomplish. They want to improve the user experience of some things, of some applications, and we'll talk about that in just a minute. They want to have some independence as well. So they want to explore this cloud thing because they think the cloud thing is going to help them with these challenges. And in that process, though, they don't want to have a hard connection back to their data center from the cloud. They don't want to take a dependency on their data center. However, they have these scenarios where they need some interactions back to their data center. So things like Active Directory for identity. All of their users, that 5,000 user base uses Active Directory. They want portability as well. They don't want to be locked in to a cloud vendor. Anybody have concerns about vendor lock-in? Yeah, so that's a common concern in the cloud. So they don't want to have that. They want portability. They want to avoid retraining their developers, right? They're all .NET, ASP.NET, Visual Studio sort of developers. They want something that's familiar for their developers. And they want to be careful about the dependencies that they take on as well. So we're going to apply a very simple sort of agile lean thinking method, and we're going to try some things. We're going to learn from our trials and our experiences, and we're going to try to fail fast. So if we do have a failure, we want to know about it fast, and we want to optimize that over time. Make sense? So let me show you the app. This looks really complex, right? It's not really that complex when we tease it apart. We do this every day. This is what most of our line of business apps look like. So we have users coming in through a web browser, hitting a website. This website is authenticating our users back to Active Directory, doing some LDAP stuff, kind of looking at the graph of our users, figuring out who managers are, cost centers, things like that. We have user profile data, some extended data that we store off in membership profile data from the membership API and ASP.NET. We log events out to the event log. We store some files out to a file share. And we store our application, our relational data for our application in a SQL server. So thus far, it's not terribly complex. It just looks complex on the board, right? And then we have all those legacy systems, right? We have the AS400 sitting back there that actually cuts checks. And so we have this integration service that's picking up things from SQL Server and creating CSVs out of that, bringing it into our AS400. AS400 is outputting a CSV. We bring it back in to reconcile all that data. We also have some things going on in this file share where we have things like a file system watcher sitting here, picking up images that we uploaded, and it's optimizing those images. So this application is an expense tracking application. Very, very simple application we have. We probably all of us have this kind of application in our environment. What Datum has found, though, is that they don't have a sustained utilization on this application. They have these big peaks and valleys. So most of the time, that application is very underutilized, and then we all have these situations. Wait, here's a consultant. Okay. Maybe I'm the only one. So we all have these kinds of applications. Expense tracking and reporting is one of those where we have a deadline, and if you're anything like me, and most folks I would say, we wait until that deadline to actually do it. And that's what Datum has found as well. They have this application that sits idle most of the time, and then it goes whoop, and peaks on that last day of the month when all the expense reports are due in, right? We all have stuff like that. Well, the problem is the way we plan our data centers, we often think about utilization like this. So we have this application, we have 5,000 users. We expect half of those users to submit an expense report every month. Basically, that's going to take, if we divide that utilization out over 30 days in a month, that's going to require X number of servers, right? But that load's not evenly distributed, so that last day of the month when everybody's trying to do it, they have a terrible user experience, and so that's what a Datum is trying to avoid. So let me show you what this application looks like. Scott showed this off this morning. This is the Windows Azure portal. And I have deployed out the website. Visual Studio Live Redmond, A expense, Datum expense. So I'm going to go browse out to this service running out in Azure. And the first thing it does is asks me to log in. So this is simulating. This project is actually simulating Active Directory. I don't want to run Active Directory on my box and run in a server. So I'm simulating that Active Directory authentication. And I got a 500 error. I'll show you later that this is, it's really nice in Windows Azure websites. I can go get access to these errors. But the reason I got a 500 error is my app is expecting me to run over SSL. So if I go change that and now authenticate over SSL, this is my expense tracking application. So it's a very simple web forms ASP.NET application running out in Windows Azure. So let's talk about how we got this out in Windows Azure. So this is my web forms project. There's nothing extremely special here. Very simple ASP.NET application. I'll go crack open the web config. One of the things that you'll see here is my connection string out to my database. So this is pointing out to a Windows Azure SQL database. Maybe. There we go. So there's my Windows Azure SQL database. So all I've done here that's special at this point is deploy my database out to a Windows Azure SQL database. So let's walk through that process. It's actually quite simple. So I'm going to go down to the bottom of the Windows Azure Management Portal. There's a new button at the very bottom, and that's kind of our hub for creating everything new in Windows Azure. From here, I'm going to go drill into Data Services. I'm going to choose SQL Database, say Quick Create, and create a database. We'll say VS Live, Redmond, Expenses, choose my subscription. I already have a server, a SQL server sitting out there. If I didn't, or if I wanted to create a new one, I could do that as well, and it will create a new server for me. In this case, I'm just going to choose my existing server, click OK, and that's going out behind the scenes and creating a database for me. Now, I've already done that, but if I go dig into the database that I already have, which is this one, from here, I can manage this all through a web portal. So if I say manage right here, this will launch up the SQL database web-based management portal. So it's not exactly Management Studio, but it has a lot of basic functionality for us to do things just from a web browser. So I'm logging in. Here's our database. From here I can go design this database, which I've already created some tables. I can create new tables. I can go edit the tables that are already there. I can look at the data and run queries from here. So it's a pretty robust tool for just running in the browser. And so that's what I've done from here. I've said create our new database. I ran a query earlier and just pasted in a big long.
Is it a SQL Server running?
Yes. So
can I use Management Studio to connect to it?
So yes, you can. So let me go back over to Management Studio. I am connected to that same SQL database server here as well. And so you'll see up in this corner, there's the database I just created, VS Live Redmond Expenses, and then there's the database I created before. So I can manage that from here as well if I wanted to. I can even take a database that's on-premise. So I think this is really important as we're migrating applications out to the cloud. I can take a database on-premise, so I have this database running right here. I can right-click and go to Tasks and say Deploy Database to SQL Azure. Now, the tooling hasn't updated here. The product known as Windows Azure SQL Database used to be known as SQL Azure. So it's like a Prince sort of thing. But we can walk through this wizard and connect to our database running in Azure and choose a name for our database. Let's create a expense VS Live, click Next, and finish, and it will migrate our database out to Windows Azure for us from on-premise. Now, what you'll see when this runs is you're going to see some errors. And that's actually a good thing. One of the things this tool does is takes a look at our schema and our scripts and determines where there are issues that can't migrate to Windows Azure SQL Database. So to your question, I was a little hesitant about how to answer that. The question was, is it SQL Server? Can I just connect to it from Management Studio? So yes, you can connect to it from Management Studio. It's not exactly full-blown SQL Server. There are some restrictions. There are features that are missing. I actually had a session on this Thursday on kind of the differences in what is SQL database. But there are features missing, and there's kind of permissions that are missing. So that's important to understand. Think about it like this. We're all, we had this whole economies of scale discussion. We're all sitting on the same physical SQL server. And so there are certain system level things that Microsoft doesn't want to give us access to because we could potentially impact the performance of others sitting on this box. Anybody run like a reindexing job or a backup that kills a server, right? Yeah, so Microsoft doesn't want us to do that to everyone else running on these servers. They've restricted some access to us. In this case, I think you'll see an issue with the width. Yeah, we have some hints missing, so we're missing width. So it's not able to do it on our schema. We could make these quick changes and deploy it, but that's really useful. There's also another tool that I highly recommend that does something very similar called SQL Azure SQL Azure Migration Wizard. It's on Codeplex. It's actually a buddy of mine in Chicago. Works for Microsoft. But it's sqlazurenw.codeplex.com. Does a similar kind of thing. What you do is point it at your database. It will script out your schema of your database. Then it has a rules engine that says these things aren't supported. Go fix these. It will automatically try to fix them for you if it can. So just with hint, it would have fixed that automatically for us. And then from there, you can just deploy it out to Azure. So you can click the next button and choose your database, and it will deploy your database out to Azure for you. So those are a couple of options for migrating your data. So that's what we did in the case of our database. Pardon me? Yeah, so the question is, will that migrate views and stored procedures as well, not just tables? Yes. So it will look at all of your objects and let you migrate all of them. Triggers are supported, you can do that as well. But there are certain things that you couldn't do. So I can point you to the MSDN article of here's everything that you can't do, and you can bore yourself to death reading that. It's good stuff. There's a ton of stuff not supported. So. Yeah, so let's chat afterwards, and I can point you to some resources that'll help you with that. So, is there some other questions? Yeah, fire away.
Does that just do the schema, or what about the data in the database?
Yeah, so that's not going to move the data. That's moving the schema for you. There are tools. I can do a backpack sort of thing and package up my database and export that and then import that back into Windows Azure. So I can move my data, but this tool is not doing that for us.
I noticed you were using SQL Server authentication. What if I wanted, like Windows authentication?
Yeah, so let me take that one afterwards, or you can just come visit me on Thursday, and we'll dig into that sort of stuff in a little bit, or on Thursday. All right, so let's keep moving here, and let's go back to our website. So again, we have nothing terribly special on our website. It's just an ASP.NET MVC website. I'm going to go back to the management portal here and go to our website. Actually, I'm going to create a new one for us. How's that? So let's go and create a new website. Quick create. What do you want to call this? PS Live Expenses. How's that? And we are going to choose the region and the data center we want this thing to run in. And then we are going to choose our Windows Azure subscription. I have a bunch of these things, so that's the one we're going to use. Now this is going out and creating a website for us very quickly and very simply. Didn't have to do a lot to do this. Now we have our website created. Now I want to publish to this website. So back over in Visual Studio, I have this very simple app that would run locally if my emulator wasn't posted up. And I want to publish this to Windows Azure. Now, this is the web deploy publishing wizard for Visual Studio and Windows Azure. It lets me import a publish settings file. So I can go over here and find a publish settings file, which I would go get from the Windows Azure management portal. Right here I can download our publish profile. Or the tools allow us to add a subscription and just look at the websites in our subscription. And so these are the websites that are part of our subscription. There's the one we just created. So I choose that. It's downloading the publishing profile for me. I'm going to put our HTTPS on here and say validate that, make sure it's good. It is. So I'm going to click next. And then it's going to ask me where do I want to look for this database. So I've already deployed this database out to the cloud. There it is. So there's our connection string. I'm going to choose next. And it's going to give me a preview of everything I'm going to deploy out to Windows Azure. And from here I can publish. It is pushing out our web app to Windows Azure to our brand new website. Changed up the connection strings to point to the right database for us. We We do this business and log in, and there's our application running on Windows Azure. So this is great if you have a very simple website or some web services. We're actually using this right now with a customer that's building mobile apps, and we're building a web API and a database for these mobile apps. That's all we need, so a website works really well for us. We can expose SSL and create our own CNAMEs, point our own domains to it. So websites are a great feature if we have a very simple website. Questions?
You told us a connection string in your code. How did you get it from you?
Yeah, so the connection string, if I go back over to the management portal, and I'm going to go down to database, SQL database, and this is the database that I'm using. There is my database server that I'm connecting to. So it is a URL at database.windows.net. And then I created, when I created my database server, I created a user. And so I'm logging in with that user. And then I can also dig in and actually see, if I wanted to see all the databases on this server, I could do that as well. But that's my connection string, basically, is that server. Yep.
I think that works well for a small scenario. But I think most of us, when we have to deploy, I can't deploy to my production server. I send it up to the deployment and release team, and then they handle that. And I'm sure my organization is not going to say, Garfield, go ahead and do it like this.
My customers wouldn't do that either, right? I deal with SOX compliance and all that sort of stuff that we don't even get to see production. So I have a lot of different ways I can do that. I can script out the deployment, and I can do that with stuff like PowerShell or what have you. I also, if I go back to the websites, let's go look at this again. If I go to the dashboard, you'll see I have a lot of ways to connect to this. So there's FTP. Here we go. There's some FTP access, so my folks could just FTP this stuff up, or they could do the web deploy themselves, the ops folks. I could even get, if I could get to a scenario where I was comfortable doing a continuous deployment. So if I had like automated testing going on, and I knew without a doubt that my automated tests were so good that I could deploy whatever came out successfully from those automated tests, I can wire this up to my Git repo or my TFS online account, and it would do the deploy for me. So that may not be the case. Most of us, anybody comfortable? Anybody have automation that they're comfortable with doing?
I was just going to ask you, did you ever do continuous integration with the deployment scripts wherever?
Yes.
PowerShell you use.
Yes, you can do PowerShell, but you can also just wire it up to your.
Yeah, we use Bandos separate the script with PowerShell.
Yep, absolutely. Yeah, you could do. There's also a command line interface that's cross-platform, so you wouldn't have to use PowerShell. There's two options in it. Yep.
On-site TFS, can you use TFS deploy, hook it up to the?
Not on site. It has to be TFS online or Team Foundation Service or whatever we're calling it today. So, Microsoft branding gets a little confusing, right? Names change a lot. But I could do that. I can also do, so let's get really radical. Let's say I'm a startup in the Valley. Anybody work in Silicon Valley like in a startup? What's that? Yep. And that's what we just demoed, right? Yeah, so in that case, right, that we just did, we had really no dependencies on Azure and on anything specific, anything out of the SDK. So we just picked up and moved our website to Azure, just like we would running it on-premise. We just deployed it out to an Azure website. Exactly, same process.
If I have things like top-down tools that I have within the application before,
Like legacy stuff sitting on the server? Yeah. So now we're getting into a scenario where website starts to break down for us. So websites works really well in a very simplistic scenario where we just have a web app that we want to deploy. Maybe that's a PHP app or our own ASP.NET app. But when we need to have things installed on the box, websites start to break down for us. So now we can go in 2 different paths. So I'm going to flip back over to slideware for a second. I do not want to stop that website, but I am. All right. So let's start going down 2 other paths. So what we did right now is deployed out to a Windows Azure website. Very simple. What I was going to say is if we're a crazy startup, hipster sort of thing going on in the valley, we can also deploy from Dropbox. So we can use Git. We can also tie a Dropbox directory, and it will just synchronize it from there. So crazy stuff that we can do in Windows Azure. But if websites don't work for us, so for example, maybe we need to install something on the box. Now, some of you may say, I don't really have anything special that I need to install in the box. But it could be as simple as IIS modules. Anybody use the IP security module in IIS? Okay. All right. So I do a lot. Basically, what the IP security module allows me to do is say, I only want to allow access to this website from this IP address. So for example, in the cloud, I have to start thinking about, I'm pushing out my dev and QA websites out to the public, but now I just want my internal team in my office to be able to access that. I don't want the world to see what we're developing, right? But now it's publicly accessible in the cloud. So we use things like the IP security module to make sure that only our office can get back to that website. So if you needed to do that, I can't do that today in Windows Azure websites because I have no control over the box or IIS. So with that, we can look at virtual machines, where this is a model here of virtual machines. And it's really, we're talking about identity here, and I'll show you 2 different models. But with virtual machines, I could spin up a VM. Scott showed that off this morning. Deploy my website out to a web server with IIS. Run SQL Server out there as well. I could even I could connect up via a virtual network back to my data center for Active Directory for identity. So I could use the same user store that I use on premise today via a virtual network. And I can do all that, and it's perfectly fine. The thing that's a challenge for us as developers is that's a lot of work, right? We have to manage SQL servers, we have to manage web servers. Maybe it's not us, maybe it's somebody else, but it's just a pain to do all of that. And so we want to try to minimize that as much as possible and reduce all of that extra overhead and focus on just building apps and managing data. So while we could do that, and that's one easy path for us, I'll show you another way to think about identity. So in that last model, we bridged our Azure and our own private network via VPN tunnel so that we could get back to Active Directory. In this model, maybe we would just install Active Directory out in the cloud. We might VPN and do a synchronization between the 2 or something like that. But this is all running in VMs. But what we really want to do is get rid of that management of the VM. So this is where cloud services comes into play. So cloud services is like the middle ground between websites and VMs. So it's where Windows Azure really started. And it's back to that web role and worker role topology that we looked at earlier. So in a cloud service, maybe I need to install some proprietary stuff. So you'll see some vendors out here that really, to work well, need to install some stuff on the box. So App Dynamics and New Relic. I use App Dynamics all the time and love what they do, but they need to install an agent on my server to collect diagnostics data. So in order to do that, I have to start thinking about things like cloud service to install stuff on the box. So what we're going to do is walk through that same application, deploy it to a cloud service. We're going to think about a few things. We have some goals here. We want to move our SQL database to Windows Azure. We've already done that. We want to use Enterprise Library. We want to use it for logging. And I'll show you that in action. We also want to use Membership Provider, but instead of using Membership Provider pointing back to SQL, we want to point back to table storage. Now, I mentioned earlier that table storage is this NoSQL, non-relational property bag data store. Why would we want to use that for membership provider data, for profile data? So the reason it becomes, it's a nice fit for this sort of data is it's not really relational data. We don't query this data oftentimes by anything else but like a username, and then we log in and authenticate against that username. We don't really have any complex relationships with that data. And table storage is really, really scalable and fast. Much faster and much more scalable than SQL Server out of the box and SQL database. And so table storage is a great fit for this kind of data, for user stores. It's a great fit for logging data because it's fast, it's scalable, it's also significantly cheaper. It's really inexpensive. So we're going to use membership provider with table storage. And then we're also going to deal with identity. Identity is going to be by far the most complex piece that we're going to deal with. Anybody using WIF today? Okay, not very many. Windows Identity Foundation. So we're going to talk through that a little bit. It gets a little complex, so I'll give you a heads up right now. So let's talk about WIF really quickly, since there aren't a lot of people here that are using it. Who's familiar with things like WS Trust, WS Federation, the WS Identity standards? Okay, so one person. So it gets pretty complex, but basically the idea is that I'm assuming I am not going to be able to build VPN tunnels and any sort of direct connectivity back to all of my partners around the world, whether that's a cloud vendor or maybe it's another business partner of mine, to authenticate against my Active Directory store. So with that assumption, we need another way to do that. And so there's a whole set of web standards. We see this all the time in practice on Facebook and Twitter, out in the cool web technology startups. But this OAuth sort of thing going on where I can say, yes, allow access to my stuff. They get kind of a token and they use that forever. And they know a little bit of stuff about me. They know, my name and my email address and stuff like that. Maybe I share my gender and my birth date and all that stuff with them as well. So using those same web standards, WS Trust, WS Federation, OAuth, we want to do the same kind of thing with our internal Active Directory stores. So I think about it like a passport. What we do is we go to a government agency to get a passport or a driver's license. They verify who we are. They take our credentials, our birth certificate, social security card, whatever that may be. They verify that we are who we say we are, and they issue us a passport. And that passport is a set of claims that somebody that everyone trusts, whoever that passport office is or country or what have you, everyone trusts that organization. We know it's good. And so then I'm carrying around this set of claims. Now this set of claims in the passport case says I'm from this country, here's my name, here's my date of birth, all that sort of stuff. On a driver's license it may also have my weight, height, and all that stuff. It's not generally as scrutinized. My weight's probably not quite accurate on my driver's license, but my DMV said it was true. So we carry around these claims with us, and then we go to another vendor, another partner. So we go to the bar, and the bar says, oh, yep, you're 21 based on your driver's license or your passport. Yep, these guys who we trust issued. That exact same model is what we're talking about in these web standards for identity. We go somewhere that we trust, authenticate, they validate our credentials, they then pass us back a set of claims. We keep those claims, we hold on to those, and then we pass those back with all of our HTTP requests in the future. Then the party that accepts those, whoever we're authenticating against, says, do we trust the provider? Yes. Okay. Then we trust that these things are true about you, your name, your email address, and all that. That's how we do things like bridge Active Directory on-premise with a cloud vendor like Windows Azure without creating that VPN tunnel. And so for Datum, they didn't want to create that hard dependency back to their data center. They wanted that independence from the cloud provider. So using these technologies, we're able to do that. So I'll show you how that works with WIF here shortly. I've talked through this a little bit on the model of how this works, but again, our user goes out to the trust provider in the passport case, and we pass those set of claims around that we get back. So let's talk through authentication. I'm going to go over to another project that I already have running here. And this is the same Datum application, but we've made some tweaks. Let's talk through identity first, because it is complex. I don't even know if we want to do that first, actually. It's so complex. Well, machine crashed, so we'll have to go out here, put out some stuff that I saved. All right, so let's go look at the web config and see what we've done differently here. At the bottom of our web config, you will see this whole block here. That's Microsoft Identity Model. This is Windows Identity Foundation. Now this block of code is configuring up ADFS for us. So for those of you who have Active Directory running on premise, there is also a server called Active Directory Federation Services that sits in front of your Active Directory server. Often what you would do is put this out in the DMZ. So in the area that's accessible to the public in your network, in your data center. And then Active Directory is generally going to sit behind your firewall. There's going to be a tunnel between this ADFS server and Active Directory. Active Directory is going to expose, ADFS actually, is going to expose all these web standards so that folks can come in with this passport sort of web standards, authenticate, and then carry these claims around. So this block is configuring all of that. So we're saying here, scroll around here. We're telling it, we have a couple of user URLs. So we're telling it, here's where people authenticate. And then we're also telling it, where's our application. So here's the application that we're coming from. And we have some certificates in this whole handshake as well to deal with kind of encryption and authenticating who we say we are, and all of that sort of stuff. Now, there's an easy way to see all this, assuming my project isn't completely flaked out. And it is from the reboot. All right, so there is a tool, a wizard, and I can point you all to the URL to get this. Actually, let me just show you inside of the extensions. So there's this identity and access tool that you can download that makes it easy to configure all of that WIF stuff. So it's part of the extensions and updates manager in Visual Studio. So you're looking for identity and access tool. And what this will do is give you a wizard to walk through. Yep.
Can you, the certificate that you store thumbprint, can we use it as subjective?
No, it is the thumbprint.
Right, using the single thread scenario.
Yeah, no, that is the configuration.
What is that? I never thought.
I don't know. I didn't build this product, right? So if you download this identity and access tool inside of the extensions and updates, this will walk you through configuring that block of XML and provide you a wizard to do that. All right, so we've configured with in our web config. If we scroll up, zoomed way in, so I'm looking for it. You'll see that we have this new request validator in our pipeline. So we've changed out the way the HTTP runtime is validating our requests from the default ASP.NET mechanism. And the reason is, what we are going to do is pass these claims around from ADFS for authentication, and it's going to be XML, and the default validator will kick that out and give us errors and say, no, we don't like you passing that around. And so by pumping in a different validator, I'll show you that, we're basically telling ASP.NET not to kick that XML, those XML characters out. So you can get this block of code. I'll point you to where all of this code exists, but this will be something important that you will need to do when using WIF. Okay. Now, our identity and our principal have changed. For those of you that are familiar with security in .NET, we have these principal and identity objects. We now have claims principal. And so let me go show you how that works. So now on our thread, we still have a principal being passed in. But we have this new claims principal that's coming in, a new type. And so what we are doing is we are grabbing all of those claims, and in a very similar way that we would do it, we would check for roles on our principal and our identity objects today, using this new claims principal interface. So it's a little different than what we would normally do with, LDAP and the ADFS or the AD authentication, where we're looking for roles. We now have a set of claims being made about our user. So we're pulling those off, and let me show you, dig into kind of what that looks like for us. So we've set up a couple of types of claims. Now you'll see we have these web namespaces out here behind them to define these claims. That's how it is a web standard. It's a WS star standard. So that's how it works. We've set up claims for organization, cost center, and manager. So in our application, we need to know, are you a manager? Can you approve these expenses? What's the cost center that you're tagged to, and what have you? So we have these claims types that we've configured. Here's our namespace, and now that's what we're pulling off of our principal. Now, if we go a step further, and we look at our user, this is where we're actually pulling the claims off. So, saying get the claims for the current user, get role type, for example. In this case, we've established, here's our class for user. We're pulling those out using that claim helper class and those claim types that we've configured. So that claim helper class is also going to be something that you're going to care about as you start dealing with this federated identity. Okay, so now we've got an identity squared away. What happens is we hit our application, it says we're not logged in, passes us off to ADFS. We authenticate, we log in via ADFS. It sends us back to our application with our set of claims as to who we are. It's trusted because it came from a trusted provider, all is well. Now we have some things like data. We've moved our database out to Windows Azure, but there are a couple of things we have to think about. One of those is something we don't often think about in our own data centers, but that is what happens if we have a blip, a hiccup with connectivity back to our database server. Does anybody think about that in their own data center? Okay. Normally in our data center, we just expect our database servers to always be available, right? If we're building a web app as a developer, we just expect it to be there, right? And the application crashes in the rare event that, hopefully rare, event that it's not there. Anybody build their applications differently than that? Anybody expect the database server not to be there? Okay, so some folks, that's good. You don't know what the ops folks are doing? Oh, right. Any IT folks in here? Any ops folks? Okay, good, so we're not offending anybody. But they don't know what they're doing, right? So, in Windows Azure, SQL database can have blips. It's not uncommon, actually. It's not a long-term blip, but it works like this. I'll talk about this a little bit more tomorrow. What happens in a SQL database is this. We're all sitting on that same database server. Somebody runs some big operation, or a few people are running some big operations that's giving us terrible performance. Microsoft sees that. The awesome thing that they're doing for us all the time is they're building a high availability cluster all the time for us in SQL database. And so all the time, there are 3 servers replicated with our data. And so if we're sitting on a server and Microsoft says, this thing's overutilized, you need to go to another server, they will kill our connection, bounce us to the other server, and now we just had a blip and we lost our connection. Right? So, with that, we need to deal with that somehow. So, I lost my bookmarks, so we are just going to do a little search here, and I will show you how we do this. So the Microsoft Patterns and Practices team have an application block called the Transient Fault Handling block. Anybody using Enterprise Library today? Okay. So you're familiar with the Enterprise Library application blocks, you're familiar with Patterns and Practices. The same guys produced this Transient Fault Handling block. Because that's what that blip is, it's a transient fault. It could happen across all of the Azure services, all of those storage services, all those dependencies that we take on, we could have this transient fault case. So what's happening here is they've built this block that says, we know when this is a transient fault. There are status codes that get sent back when it is this transient fault case, and they inspect those and say, yep, that's what it is, so we should handle that differently. And what you should do is retry, because it is just a short-term blip. So you want to retry whatever it was that you were doing with that connection. It'll reestablish the connection, everything will go smoothly. So something we don't often think about in our data center, we just expect storage in our databases to be there. So with the transient fault handling block, we create a retry policy. And this is something that everybody should do when working with these services. I'm just going to tell you straight up. Otherwise, you're just going to have challenges. It's not uncommon. So here's our retry policy. We've just said give us the default retry policy, which will retry a few times over a certain period of time, and then stop. And then the way we use that is very simple. So here we are working with this EF sort of model, and we're adding objects to it. We have a whole bunch of data things that we need to do. This is in our data access library. So we are, in this case, we're saving expenses, and we've added some receipts and all of this sort of stuff. And then this line of code right here is the one that matters for us. We say, with that retry policy that we created, do this. And what we want to do is save all the changes on our context from EF. And so what that will do is if there's a transient fault that occurs, it will retry that, and then retry that, and then eventually fail, and then we will hit our failure and our exception logic. So, if you're building applications using SQL database or the storage libraries, you definitely need to check this out. It's from Patterns and Practices. It actually originated from the customer advisory team. The CAT team at Microsoft with Patterns and Practices has picked this up and put it in Enterprise Library. Now, we can configure, because we are using Enterprise Library, the Windows Azure variant of Enterprise Library, I will show you that we can configure this in our web config and say, here are the policies that we want to work with. So there's our different retry policies. We could have an exponential backoff policy that says, we try it once, that didn't work, so wait 2 seconds, try it again, wait 4 seconds, try it again, that sort of thing, instead of just being a linear bam, bam, bam. So, all right. And again, this is an Enterprise Library. We pulled in, at the very top, we pulled in this section from the Enterprise Library. All right, one more thing I want to show you is Diagnostics. Who in here, in your web apps, or any of your apps for that matter, could tell me what's going on in your application right now? No? Would you know if there are exceptions occurring or if you're having performance problems? Yeah, some people?
Yeah, Elma.
Elma? Okay, perfect. Yeah? Splunk? Perfect. But most of you don't feel comfortable or would be able to deduce what's going on in your applications right now. Is that is that an accurate statement? Okay. So how would you debug applications? If somebody said there's a problem right now going on in production with our expense reporting app, what would you do? Tracing, okay. System diagnostics. Log in, right? Yeah. We're probably like all embarrassed to say it, right? But probably most of us, we would talk to our ops folks and say, hey, can we log into that that server and see what's going on. We would go browse the event log, and we would look for weird things going on in the server, right? Yeah. We don't have to lie about it and be dishonest. Like, I've been there, like I've done it, right? So that's what we often do. I heard some things like Elma, tracing, diagnostics. So in Windows Azure, this problem gets exponentially larger. In our data center, we might have a web server or a couple of web servers running our application, but if you're like me and you build these massively scalable e-commerce properties, we may have hundreds or thousands or tens of thousands of servers running in Windows Azure. And now, remoting into that box becomes a little more difficult because finding the right box to remote into may be impossible, right? So what we really need to do is consolidate all that data somewhere. So I'm going to show you a couple other cool pro tips here. In Windows Azure, there is a module called Diagnostics. And what this module does is it allows us to configure a number of things in our cloud service to collect. There is a default configuration, but we can configure a lot more than that. So I'm just going to walk through the things that we can look at. So there are, at the very top, you'll see infrastructure logs. These are things that occur in Windows Azure modules. So there's a remote access module in Windows Azure. The logs for that would be collected here. Things that would happen in the runtime itself. Then if we go down, we see logs. And logs are like trace logging that would occur. So I heard things like Elma and tracing and stuff like that. If we're writing out using the system diagnostics and the trace stuff built into .NET, that's where it would go, is this logs block. Then we have directories. Directories have some kind of pre-built, pre-installed directories. So for our web apps, we often care about things like failed request logs. We care about things like just the raw IIS logs. And so we can use this directories module to configure IIS logs, failed request logs, crash dumps, that sort of thing. We can even configure performance counters. In this case, I just have one, which is processor time. I normally have a template that I usually use that has a whole list of perf counters by default that I log. And then we could also include our own custom performance counters. Who in here uses custom perf counters? Maybe like a ticker every now and then or something like that to count transactions or what have you. We can grab the Windows event log data, and all of this is being logged back to our storage account. So we talked about table and blob storage earlier. Let me show you how this works. Now in Visual Studio, I can look at, Scott showed this off a little bit this morning, using the Server Explorer. I can go look at things in Windows Azure. So there's Windows Azure Storage. If I go load up blobs, there's my IIS logs. I can go open this up, it's downloading it. Not seeing it. But I can go open up these files. I can go look at our tables. But this tool is really, it's not terribly robust. So if you are working with Windows Azure, you should get familiar with these guys. These guys make what I think is the best tool for working with storage in Windows Azure and working with diagnostics data. Now, Serverata is a company that was acquired by Red Data a while back. It actually started by an Azure MVP. He built this cool tool because he realized there was a gap in Visual Studio, right? And built a cool tool and did really well, and Red Data bought them. But let me show you how this tool works. Serverata is not going to find what I'm looking for, so Windows Azure. There's nothing to this. Alright, so it's loading up. Oh, of course, there's a new update. I just had this open like 30 minutes ago. It's fast. It is a click once deploy, so that's kind of nice. So this is Azure Management Studio. There used to be two tools, which was Cloud Storage Studio and Azure Diagnostics Manager, but they've consolidated, after the Red Data acquisition, they've consolidated into one tool. And you can see I have a much nicer way to look at this data. So here's my logs data. This looks similar. I can run some queries, but if I'm looking at Blobs, for example, I'll go back to this IIS log. I see my directories here. I can drill in and crack open that log. So that's my raw IIS log. So this tool I think is great. Yep.
Not the IIS log or anything, that we log.
The trace logs, right? So that happens under the logs table. So anything that we were to trace out using system diagnostics and tracing, you would see right here. So these are all of our tracing messages that we traced out in our application. Now, you may be saying, okay, that's great, but it doesn't look radically better than what Visual Studio provided for us. So when we're looking at diagnostics, what they did was they built in a great tool for working with diagnostics. Now I'm going to take this back to historical data. I don't know if we're going to see much here, but we'll see. And we don't have data points, of course. So let's go do this. I'm going to look at performance counters for the last 4 hours. So there's our datum application running, and there's our perf counters that we're visualizing. So there's our processor time that we're visualizing using their tools. So that's really nice. When an exception occurs, I may want to go back and look at my trace logs to figure out what's going on. Again, I can say, configure how often I want to go look at that data or how far back I want to go look at that data. And you'll see, much like working with the event log and the event viewer, I'm seeing the messages that I've traced out. And I can configure the level as well and say, I only want errors and I only want warnings and that sort of thing to show up. So I think this tool is great for working with diagnostics. There's one thing I didn't show you in how we configure diagnostics. So again, we are using the enterprise library. So if I go back to web config, collapse some of these things down, you'll see I'm bringing in the enterprise library, like logging configuration section here at the very top. And so then if I go down here, I'm configuring how, what I'm collecting using the special trace listener. So here's the Windows Azure trace listener from the enterprise library. So we would need to do that, and that's going to log out, using the Windows Azure trace listener, that's going to log out to Windows Azure Diagnostics. Okay. Yeah.
You focus on another configuration file for diagram. How do you generate?
Yeah, so diagnostics WAD config. So let me show you this again. You will need to Bing this. I have to be careful. It's tough to see that. You can Google it as well. That's what I would do. But diagnostics.wadcfg. This will take you to an SDN article, and it will tell you everything you would need to do to configure diagnostics. This is the declarative way to do this. There is also an object model. You could do this imperatively in code if you wanted to. I would recommend this way. I often do a full session on diagnostics and debugging and monitoring, so we don't have time to talk about why. Catch me afterwards and I'll explain to you why I think this is the better route.
So the second question is, if it turned on and production, does it not degrade the performance of your?
No. So the question is, if you keep this on in production, is it going to degrade performance? You are not going to notice the overhead associated with this. Now, you can set, I guess it depends. If you are tracing things out all the time, you may notice overhead. That would just be the case in your normal application. If you set the levels appropriately. So in here I can specify, so you'll see in that logs block, I'm saying only like filter like this level of logs, like only grab, or grab for post in this case, which is grabbing everything for me, but I can choose to only do warnings or errors or what have you. So I don't want to do that. Okay, so we've moved authentication and identity, we've moved data, we've moved diagnostics information. So how do you, what's the right way for you to think about this? I think new brand new greenfield apps are an easy case to start thinking about Windows Azure. Scott mentioned it this morning. That's really easy. If you're going after existing applications, I would not recommend you go back to the office and say, hey, I saw this new cool Windows Azure thing. I think we should just start moving all of our applications to Windows Azure, right? You gotta have a business case. The business case may be that there's a capacity shortage in your data center. You guys are running out of servers, you need to buy more. Instead of buying more, use Windows Azure.